Hello. In this video, I'm going to introduce you to the Dockerfile. So at this point, you should have used the Docker CLI, and you should have seen how you can create shell scripts that use Docker CLI commands in order to embed your steps of interacting with Docker to do different things into some sort of text code that you can then save to, for example, to GitHub and share with others. So now we're going to level up a little bit and build our own Docker image. So that image is going to be the base from which people can run containers based on our image. So what we'll do, just to keep with our organization scheme here, is create a folder called Docker, and that's just going to keep any kind of Docker related configuration files that we'll write. And we can create a new file called Dockerfile, which is the default, but we can also give it a different name. So if we give it a different name, we're going to have to specify that file name when we run the docker build command to build our image. So let's say we rename this to something like go hello world Docker. So this is going to be something that did what we did in the last demonstration with compiling a Go program and then running that Go program. What we're going to do is be smart with this and say, well, a lot of the work was just to compile this Go program. Why don't we compile that program at build time and just leave that program inside the image? And then when somebody goes to run our image, they get to simply run that executable that we pre-compiled for them. So this is going to show you the difference between build time and runtime. So images are created at build time, and then images are used to create containers, and then those containers can run things at runtime. So executing commands, like for example, if you run the sh program inside of a container, that's runtime. But if you're running a run command inside of a Docker file, that's build time. So let's see what I mean by this. Docker files have their own format, and you can look at the documentation on Docker's website. But it's kind of like its own little language for setting up containers. And the basic format that you start with is from a certain image. So we'll just follow this this technique we've been using before. We'll say from Golang, and we could give it a name. We could say sure as build. Let's say compile Go. And then we can specify different things. We could even pull in some of our code so that Copilot can reference it. And we'll just highlight this, Control / to comment it out. And so from compile Go, we will use the run command to run a particular command that we have. So we can, for example, run the Go builder. We can run go build program.go, but we don't have a program.go. Remember, Docker containers have their own file system, and so this is not going to work. We can try that, but there is no such thing as program.go. And by default, we're going to inherit the default command or the default entry point of the parent container. So whatever this program was meant to do by default, if we just were to Docker run this, that's what's going to happen when we run our built container. So let's see what happens. What is the default behavior? We can do IT to see what happens if we want, but let's just go Docker run this, and we can add in our RM and our name go C. Docker run RM name go C, that container with no arguments. See what we get. Just exits Docker PS. It's not running, so the default command didn't seem to be useful to us. We can try with -it to see if there's a default shell command, and it seems like the default command is the shell. So we can Control D to exit and then remove because of the remove flag. And that default behavior might be fine, but we might want to override that. But first, let's look at building and running our custom container. So maybe we want to call our container golang :custom, or maybe we could put our username in case we were going to push this up to Docker Hub or something. So we could say, I'll just use my GitHub username. I don't have a Docker account, but I'll just say, you could name these really anything you want. I'll say Docker build, and remember I'm in the root of the project, ls, I'm in the root of the project, so I'll need to do a Docker build, and I will say Docker build -f for file /docker /go go hello world. So I'll just copy relative path, and the context is going to be dot oops, somehow our Docker folder is not showing up here. Let's do a Control-Shift-tick mark to open a new terminal and see. Oh, we were in the DP test. That would be the problem. I was in my test repository, so I'm gonna ls now and do the same command of Docker build -f /docker/ and I just use tab to tab complete, and then I'll give the build context of dot, and we'll get probably an error on that, and so we're not really getting any informative output necessarily. So we can say Control I, how to print standard out of build run command to our standard out, because it kind of runs the build commands in a little sandbox. Oops, and I lost that. So let's ask over here in the chat, say pound terminal last command, have Docker build share standard out with us, and we'll need no, I want the standard out of the run commands. And this is correct. I need progress equals plain added as a flag. So that's in the Docker documentation as well. So we'll do -- progress equals plain. And so now we're going to get the output of those programs, and it says that so this program returned no module provides package program.go go mod file. So this is the response that the Go compiler that we're running is giving when we're doing that progress plain. We can see what it's telling us, and then we're also getting what the Docker output of the build process is. It failed on running this go build command because there was an exit code from that Go program from the error internally. So there's kind of two layers. There's the build error, and the build error was triggered by the command error. So next, we can solve that problem by copying in a file here. And to do so, we'll just create a run command that does run cat of, let's just do /src, because we know that this has a source folder and program.go, but we're actually going to have to put program.go into there. So let's try a C copy of, we'll do ./src/program.go into source program.go. So it's going to take our local ./source/program.go and copy it to the container /source/program.go. And so it's doing this at build time. So let's see what happens here. We get the copy, that succeeds, and then we run cat, and we do get the output of the program. We see the text of our Go program. That makes sense. One key here is that the build context was specified by this dot. So this is the thing that the context for your Docker build will often be dot, but if your paths inside of your Dockerfile are relative to a different folder, it might need to be something else than dot. So for example, if my context was Docker, was my build context, and I click enter, I should see an error. And the reason is that the copy command is going to fail to calculate this because essentially it could not find program.go in ./source because the context is now the Docker folder. So the Docker folder has no subfolder called source, which has a program.go in it. So we would need that to actually be relative to that folder if that's how we're going to run the build command. So that's perfectly fine. We can say ./source/program.go, and then let's see if that works for us now. So it seems that it doesn't like this either. So let's just go back and do ./ and make our build context of dot. And we get that output just fine somewhere up here. Somewhere in there should be the output of the cat command cached. So it didn't give us that output because it's already cached that build step. Normally you wouldn't be running things that you want to see inside of the builder because the builder is sort of already debugged for you. It's just supposed to run things top to bottom. But we know we have that program.go in there from before. So now we can go ahead and build that program.go. But first we would either need to pass this path or we would need to change to that working directory. So we'll do workdir source. And let's try this. Running our Go build. So once these steps have been done once, if you don't put anything above them, they'll be cached. And when the build runs again, it will be faster because it's already done those certain steps. So we're seeing success, hopefully. And then we have where did our image go? So by default, it's not going to be given a name. So if we do Docker images, we're going to see that we have a couple of images we've built, pretty big in fact, but they are not they're not tagged with anything. They have no name. So we should go ahead and copy these image tags and Docker RMI remove image for those IDs. Docker RMI. And then if I do Docker images, those images are gone. And now we can do our build command, except we can pass -t for tag, and we can pass the tag of, I'll just use my username, njg4ne / we'll call this Golang, and we'll give it the tag the version essentially of just custom. And then I'll do it, it'll cache all those steps and basically just name it. And I can do Docker images, and I should see that njg/golang, and the tag is custom, and it's right there about a minute ago. So now that is essentially my my image name that I'm going to use to run this. So that'll be something like docker run --rm--name go custom c, or we could just use go c. We don't need a workdir necessarily. We know the default command is going to be inherited from this image because it was based on this image. And then we can run -it, and we'll do the container name, or the image name, sorry, which is njg4ne/golang : and then just like this was our base image if we were running it, and then we can run the default command is going to be the shell script, but we can also specify that implicitly like that. So let's try this command. And we have a shell, but if we do ls, we'll see we have our program.go. We're not passing any volumes, so our program is not getting mapped through a volume. It was actually put in there at build time. It was statically copied inside of this file system, and then it was compiled at the time of the build of the image. And now that program just sticks around, and we can run /program. We don't even have to compile anything. And so if that was the entire purpose of our image, this would be exactly when we would want to specify either the entry point or the command. There's a little bit of a difference. You can refer to the docs on that, but we would want to specify one of those as what this container is supposed to do. So I'll just do that as the command, and the command will be program, except where is that program? It's at source/program. And I could go one more and check ls/bin. Okay, is there a stat bin/program? So no such file or directory. If I were to cp or mv move, copy or move the program that's in source to /bin, and then I did which program, I would see it, and I could just simply type program, because bin is on the path by default. So I could do the same thing inside of this container, where I could even just specify build. We could say build, and we'll say -o for output. This is the go flag for where we want the thing to go, and we'll say put the output of this build process to /bin/program, and then we will just run program as the command for the container. So since we made changes to our Docker file, we can't simply rerun the same image that we've already built. We actually have to rebuild that image. So we'll go and Docker build this. That was done in 20 seconds. Since we use the same tag, we're actually going to override the image we had already built. And so we can run that image. And we overrode the basic command that it's going to run, the base command that it's going to run right here. So it's not going to run the default program. But if we Control D and do that again, but we just take off the override for the command, we should just see it run hello world, and then should exit, and then it should delete itself because of the RM flag. So if we do docker ps, everything is clean and gone container wise, and we just had run the image, so sort of a one-time run and leave. And so this seems to work pretty well. Now the downside is that we have some pretty long commands that we have to keep track of. So luckily we know how to write shell scripts, so we can go ahead and create a new shell script for that. So we'll say run go Docker with Dockerfile.sh. And in here we can start to drop some of our big build commands that we don't want to lose track of. So I'll hit Control B to hide the left bar. And we don't really need progress plain because that was just for debugging. We do like this tag to be here. This might need to be specified from the user. We could even take that from standard input, but I'll just I could even just take this off and just do Golang custom. Now you can't obviously push to the Golang Docker hub, but it doesn't matter for the purposes of local development because it's just going to be on your own container or on your own computer. So you can make your own custom tag of Golang. If you want, you can even override one that you pulled down, but we'll just do it this way so that it's not specific to my username. And we're gonna docker build -f. So this is gonna be very specific on the person who's executing the shell script being in the root directory, but that's fine. We can just tell them to do that in the README. And then we're going to need the run command as well. And we need to change the image name to match. The default command should be in there. And to double check that this works, we should make sure Docker images. We should make sure that this command will work exactly as we told them, even once we delete any images we have sticking around. So I'll do Docker RMI, pass that ID, and pass this ID as well. Alright, and then let's take stock of what files we've changed. Git status. Hopefully you can see how Git is helping us keep track of things here. If we git add dot git status, what did we change? We got a new file, the Dockerfile, we got a new script. Those things kind of go hand in hand, so they could potentially go in the same commit, but we'll want to test them first. So we should add to our README to tell our users how to do these things. And I'm just going to move the prerequisites up to above the shell scripting specific thing because these are going to apply also to this. So prerequisites are going to be there, shell scripting, and then we'll create a new one that is we could even put our warning. Be sure to run all listed commands from the root of the repo unless otherwise specified. So getting started, we'll say, whoops, we're okay, yep, important, be sure to run all listed commands. We'll put that in the general section, and then we'll have the shell scripting section with getting started, and then we can have the Docker custom Docker image. Getting started, you'll run script / I'll copy relative path. So ./script / run go with docker.sh. Let's take a preview. And we got to update that text. It says I will build Docker image with a Go program pre-compiled then I can run it when creating a container from it. A shell script gives these commands. Or call this running as well. And now our README looks pretty nice, has different sections for shell scripting, running, and let's just make sure the command we gave them actually works. So I will ls pwd, I'm in the root project, I'll run that command I told them to run. It will build the image. And we get hello world and it exits. And Docker PS, we still have no containers running. Docker images, we have this image now. The only thing that we might want to do is, give an optional cleanup command in there, so we could add to the shell script something like optional remove the image. So we could do docker RMI like that, and we'll comment that out, and we can tell the user in the README that they should do that. So we'll just say running, and then we can say notes if you want the image to get deleted, uncomment the corresponding line in, and we'll say copy relative path, and we'll call it this. So this is just to create a little link for them. They can click on that and go right to the file. There might even be a way to specify the specific lines, but I'm not going to go crazy with that. If you want the image to get deleted, uncomment the corresponding line. And there we go. Kind of the two sections here are those things. We should probably test it as well. And it runs hello world, and it untagged. The big thing to see is Docker images. Is the image still there? Nope, it has been deleted. Another thing that you can do to remove some of the intermediate steps of the build process, all of those cached layers, is you can do Docker images prune, I think. Docker image prune. And -F to actually delete. There was nothing to reclaim, so it didn't do anything, but that's one thing. And to do both your images and your containers, you could do a Docker, I think it's Docker system prune, and I'll say no, but you could do that with -F to prune all your exited containers and your dangling images, and just free up a little space on your computer that Docker has occupied. So let's see where we're at. Git status. And we've edited our README. We tested what we added to the README, and we have these two files, the Dockerfile, the script, and let's just git add dot git status. We could just consider all these changes a new feature. We're adding a new feature where you can pre-compile the Go program into an image and then run that image. So we can just make our commit tell that. Say git status, git commit -m, adding a feature to pre-compile Go inside image and then run in container, or run program at container runtime. And now all those changes from the README to the script to the Dockerfile, those all kind of were the same type of thing. So that's why I had added them all together, and I'm going to commit them together. And that those changes make sense to go together. Now, be a fine time to git push. And then the last step, if you were going to share this with someone, you would want to pull down, reclone your repository as in a different local folder, and test that the new steps that you added to the README actually can be done without any local files that had hung around in your repository. And the nice thing about like these links is that someone could click this and oops. Yeah, well, there's a bug here apparently. Because this link is using the Windows link structure, so it seems to work locally, but not. Oh, it's because of this backslash. We need a / there. So git status, git add readme, git commit -m, fixing link / direction. See, once you get the hang of it, it's really quick to make changes, like stuff like that that's broken. Hopefully that works now. Yep, that works. So that way you have really nice commit history that tells you this story of how this code base has evolved. Adding initial README, adding a basic shell script, adding a Golang program file, script, running inside Golang container, organizing source and script code, adding hello world program, modifying the shell script to compile a Go program with one container and run it with another, ignoring big binaries, adding instructions and docs for Go script, adding a feature to precompile, fixing link /. So that history is just going to keep growing, and people can go and review those commits if they want to see how things have evolved over time. And all those changes are going to be saved, which is great, because we can go back if we want to go back to a different point in time. We can use those commit hashes to reverse the clock, essentially. So I think that will that'll do it for this one. You've seen how to build your own image based on an existing image from Docker Hub, and what the advantages of that are, in that you can separate your runtime from your build time.